sing a happy song together, and we'll all be a happy family.
Well, hi and welcome back to the channel. So, this is another supply circuit that I've drawn out for another radio I worked on some time ago. Stellar Portable. It's a battery valve one. I don't know for sure the exact voltage it was on. It was 1.5 volts for the filaments for sure, but I think it was something like 72 volts for the HT rather than the more usual 90. It's medium and long wave as usual. Now this one I did build a mains supply for it, but in the end I never did get the 1.5 volts to work without a huge amount of mains hum. So this is not a new project, this is just for interest really about these power supplies for these battery radios. So this all relates again back to the Vidor that I'm working on at the moment. Yeah, this little Stella, in the end I fitted a D-cell battery compartment here, so you could just put a D-cell in there for the 1.5 volts and a main supply that gave you the HT. So back to the circuit diagram. Yeah, basically what we have is a mains transformer here. We've stepped down to 20 volts, and then I used this kind of diode pump circuit to step it up and give me around 70 volts. So yeah, this is quite a classic diode pump circuit, which you can obviously look up on the internet to find out more about, so I won't go into it too much here. The lower part of this was an experimental attempt to make a 1.5 volt supply. That never got installed in the end because although I could get 1.5 volts, as I say, the mains hum was absolutely atrocious. So I gave up on that one. But what I did, you see this 4 volt winding here, I actually added to the transformer. There's somebody recently suggested on one of my previous videos that I could make an extra winding on the transformer by tucking a few turns around the outside of the coils, and I actually did try this back a few years ago now, and I managed to put enough windings on there to get 4 volts here, which I then simply halfway rectified by the looks of it, fed into a regulator, and I then did manage to get 1.5 volts, although it wouldn't have been wired up as shown here because they don't have a common ground. There's a resistor between the HT ground in the radio, which is probably another reason why this wasn't used in the end. I can't remember now, it was so many years ago. But yeah, basically that's another HT circuit using a 20 volt winding. Gave me 70 volts. You could put another stage in this. You can have as many stages as you like and gradually bring the voltage up. So you could have another stage and it probably gets you up closer to the 90 volts. Yeah. But yeah, that's just a little point of interest. And there's the circuit diagram for it. And it's very similar. All these little battery valve radios had a similar line. This one's got a DK96, a DF96, a DAF96, and a DL96. So here's the one we're working on at the moment, the Vidor Regatta Model CN420 is the one we're working on at the moment. And that had the valve lineup. We put them side by side. This one had a DK96. This one's got a DK91. This one had a DF96. This one had a DF91. This one had a DAF96, and this one had a DAF91. This one had a DL96, and this one had a DL94. They're almost the same valves, in actual fact. The main difference seems to have been that these ones, which were the later ones used in the Stella, were of lower current, only about half the current consumption, so the battery would last a lot longer in the Stella than the 1.5 volt battery would last in the Vidor. So yeah, just a little interesting point. Let's say a lot of these radios were based on the same basic circuit. There's very little difference between these two, and they use the same sort of valve lineup. So there we go. It's just a little diversion from just looking at this one alone. Now, the other thing I want to do now is to look at the progress I've made so far on this one. So, here we are with the Vidor Regatta, as we found out it's now called. Not a great deal of progress, I will explain why, but I did achieve one thing. I did get it to work on long wave briefly, and I'll explain why briefly in a minute. But basically, let's look at what's been done so far. Missing logo here, made one up, and the laminated paper printout, which should be the Vidor symbol. It's not exactly like the original, but I thought it's better than having nothing there. Now, I don't know how well I can show this on camera, but we'll try. But here is the power supply. Now, if I move the light a little bit, it'll be a bit clearer. This is the power supply that I built. Installed into the corner of the radio is the transformer, which was a lucky find, really, basically. A transformer that happened to give me 70 volts and a 17 volt winding that I could drop down for the low voltage side, isolated from each other, with all its mains protection and fuse box built in, so all that's still installed there, wedged in there nicely. I wanted to minimise any changes to the radio. Obviously I had to drill a hole through the side to get the mains lead in. Apart from that, the only thing I've done is put a few screws holding a block of wood here, which holds this in place, and it's jammed up against here, so that's not going anywhere. And for my little circuit board here, I simply put one screw through to hold that there. So, as I say, it is difficult to show it on camera, but that's essentially it. So the two capacitors at the back, that's the HT side, and then this bit here is the 1.5 volts with the regulator and the resistor on its heatsink. There's also a bank of 4 resistors in parallel there, adding a few more voltage drop after the regulator to get us down to the 1.5 volts. It's slightly under 1.5 volts, but that's probably good. Puts less strain on the valves, so as long as they get hot enough to work, I think we'll settle for that. So, what did I do? Well, First of all, we'll go back to how I got it to work, because before we were getting no signals through the chain. So I'll just get this out of the way, go back to the circuit diagram. Right, so here we have the circuit diagram of the one we're working on currently, the Vidor. So again, I don't know how clear this will be. I'll have to hold this up and hopefully I can point out what we did basically. I have a way of working when it comes to alignment that I tend to work from the end backwards if I'm aligning something that is completely misaligned, and that's why I was getting no signal through at all when I put signals in. These transformers are so way out. Whether somebody has screwdrivered it or whether these capacitors changed value significantly, I don't know. But for whatever reason, although the audio amp was working, I got no RF through here. So what I did was to set my frequency generator to the IF, which on this one is 475 kilohertz. So it's an unusually high IF, a bit higher than most normally are, but it's 475. So I set my generator to that and a modulated AM modulated tone on it, and I fed it in here the IF transformer 2 output, so that I could see that the detector did indeed work, and I did get the tone through the speaker. So it was accepting the IF frequency here, and the tone was coming out of the speaker, so I knew that this was working, and I knew already that that was working, and the audio side of this valve. So yeah, the signal is getting through here. So I then went to the anode of this valve and fed my signal in there, and I found that I had to adjust this and this an awful lot to trim these two up before I could get the signal through. So once I eventually managed to get this transformer tuned to the IF 475 kilohertz, get the signal through from there to there. Then the next stage was to obviously go back towards the front end of the radio and look at this one and feed a signal in here and see that I could get that tune up, and then finally in on the anode of V1 on pin 2, which is the anode of V1, which is the DK91. This had a 1R5 in it, which is equivalent, so that should have been fine. I'll come on to that in a minute. But anyway, I fed the signal in here, and I now eventually managed to tune up this IF transformer as well, so that I now got it IF aligned all the way through, and I can feed the signal in on here, and the tone was going through. Feed the signal in then on the input to the valve, nothing. And I was a bit suspicious about the valve anyway, so let me just see if I can find it. So here we are. So 1R5, and unlike the other valves, which were modern ones, this one's got foreign, just foreign written on it. And I kind of think it's soft, because I think I should see some getter, some of that classic sort of silvery looking, and I don't. There's a sort of like white cloud there, and I thought, well, I think this valve is soft. I've got no valve tester, and I can't really test it in the other radio without risking damaging it, so I didn't want to take the other one apart. I mean, it would work, I think, in the other radio because it's just a different heater current. But anyway, yeah, I decided that valve was no good. And so I went on eBay and bought in a DK91. Put a DK91 in there. And when this is selected onto the long wave, I did actually get it to work. And it's reasonably well. Not terribly loud, but it worked. It was acceptable. But I had to keep jiggling these valves around in their sockets. It kept cutting out and I'd jiggle them around a bit. And, it was very difficult to get it to work, and it got more and more difficult until in the end it was very difficult to get it to work at all. And I didn't incidentally get medium wave to work. So that would be another thing to look at. But what I did find, as I say, was that I could then say all these were working, because at least I did hear long wave and it was working passably well. It wasn't bad at all. I could listen to it. It wasn't terribly loud, but it was probably loud enough. I don't know how loud these things went. But why is the project on hold for a few days? Well, basically because the valve sockets are absolutely shot through. They're not redeemable. Looking at the pins, they were absolutely corroded, and I touched one of them to see if I could bend them slightly to make them a better fit, and it just fell off. It didn't even there was no effort involved. I just touched it, and it just the leg of the socket just fell off. So let's draw a little diagram. The pins in the valve sockets, they contain something which is rather like this. And that's the tag there that you solder onto, and this is inside the socket. So yeah, imagine it comes all the way down to here. So you plug the valve in, goes into there, presses these apart a little bit and makes contact. Then what I found is these are so badly corroded that if you even just touch these, they just simply snap off. They break off there, this falls out, and you've only got one side and it's even worse than it was before, and it's never going to work. So I had decided that there's no option but to order, again from eBay, some more of the valve bases. That is 4 of them, and as you can probably imagine, they are going to be a real pain to fit, because there's components several soldered onto each pin, and there's not much space around, and it's the capacity to make mistakes wiring it up is quite high. But yeah, that's what I'm going to do, is to change the valve sockets now, knowing that the rest of it, the components are all working. It does actually work. It's just these wretched valve sockets. So yeah, that's the next thing. Sorry, it's a bit of a bitty video, but I thought we'd look at the power supplies that I've tried in the past, and I was going to describe another one, actually, another power supply that I did. I can't remember whether I did describe it in an earlier video, but anyway, I do have a valve farm radio, which again runs on 1.5 and 90 volts. And many years ago, when I was a young lad, I built a power supply to drive that. So again, it was basically had the mains transformer coming in. I think I used a transformer that had probably a 6.3 volt winding. I think, again, this is all from memory, and it was years ago. Then I did something rather strange, but it works, and it's been working for years. As I took that and I put that into the other side of a 12-volt transformer used backwards. And what was the mains winding, I got around 80 volts, which I then did the usual bridge rectifier circuit. Right, the usual bridge rectifier circuit and the usual smoothing. To get 90 volts there. Then from here, I took this off and did from here forward. I don't really need to draw it because that is basically the same as I've done for the Vidor, or very similar. I won't bother drawing all that out again because it's basically the same thing again, but that actually worked. So that was a rather weird way of doing it, but I was using bits I happened to have. In those days, I might have even been at school still, but I think I was on apprenticeship. But I just had these bits, so I cobbled it together, and yeah, it's worked for many years. You do get mains hum, and I've never managed to get one where there's no mains hum, but you can get it down to an acceptable level so that when you're listening to the radio, it's not really noticeable. So yeah, that's just another little diversion into the power supplies. But really, that's it for now, and we'll catch you on the next one.
Sing the happy song together, and we'll all be a happy family.